Hello everyone, it's Daily Space Observations and welcome to episode 4 of Space News. Just a quick reminder before we start things off, the links to both of these articles will be below in the description if you would like to give them a look after I review them. Now, with that said, let's jump into the articles. For our first article of the video, we have Harvard professor believes alien junk visited our solar system in 2017. Now, if you're not quite sure what this is about, if you recall, in 2017, a oddly shaped asteroid flew through the solar system pretty quickly over the course of a month, I believe. And it was dubbed a name that I will not pronounce unless absolutely necessary because it's like this Hawaiian name that's hard. You'll see. But it's this oddly shaped asteroid here, as you see. It's often compared to as a cigar, and it had some very odd qualities that most asteroids and comets don't have. And so now we have a new study about this, and we're about to read it right now. A Harvard professor believes alien garbage visited our solar system back in 2017, and that more is on its way, saying it may have been some sort of message in a bottle. Abraham A.V. Loeb, who is the chair of Harvard's Department of Astronomy, claims an object that recently wandered into our solar system wasn't just another space rock, but in fact, a form of alien technology. The space object was dubbed Oumuamua, which translates roughly from Hawaiian as scout, having been spotted by Halikila Observatory in Hawaii. It traveled towards our solar system in September 2017 from the direction of Vega, a nearby star 25 light-years away. In his forthcoming new book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, Loeb explains how, on 9 September, its trajectory brought it closest to the Sun before blasting at about 58,900 miles per hour past Venus's orbital distance at the end of the month, shooting past Earth's on 7 October before moving swiftly toward the constellation Pegasus and the blackness beyond. At first, scientists believe it was simply an ordinary comet, but Loeb soon considered whether or not it may have been discarded technology from an alien civilization, looking at a number of unusual properties to come to the conclusion, including Oumuamua's dimensions and the way it reflected sunlight. The cigar-shaped object was at least 5 to 10 times longer than it was wide, something not seen with any naturally occurring space body experts have ever seen. Loeb explains in his book, this would make Oumuamua's geometry more extreme by at least a few times in aspect ratio, or its width to its height, than the most extreme asteroids or comets that we have ever seen. It was also unusually bright, and was at least 10 times more reflective than typical solar system stony asteroids or comets, with Loeb likening its surface to shiny metal. Then there was also the way Oumuamua moved, Loeb explains. The excess push away from the sun, that was the thing that broke the camel's back, he says, adding that Oumuamua didn't follow its calculated trajectory, but actually accelerated slightly, but to a highly statistically significant extent, as it moved away from the sun. Due to the anomalies, Loeb concluded that the chances of it being a random comet was around 1 in quadrillion, speculating that it could be space junk that had once served as a space navigation buoy used by a civilization long ago. The only way to look for alien civilizations is to look for their trash, like investigative journalists who look through celebrities' trash, Loeb says. In an article for Scientific American, Loeb explains how his book details the unusual properties of Oumuamua. It had a flattened shape with extreme proportions never seen before among comets or asteroids, as well as an unusual initial velocity and a shiny appearance, Loeb said. It also lacked a cometary tail, but nevertheless exhibited a push away from the sun in excess of the solar gravitational force. As a regular comet, Oumuamua would have had to lose about a tenth of its mass in order to experience the excess push by the rocket effect. Instead, Oumuamua showed no carbon-based molecules along its trail, nor jitter or change in its spin period, as expected from cometary jets. The excess force could be explained if Oumuamua was pushed by the pressure of sunlight, that is, if it is an artificially made light sail, a thin relic of the promising technology for space exploration that was proposed as early as 1924 by Frederick Zander and is currently being developed by our civilization. This possibly would imply that Oumuamua could be a message in a bottle. So, that's the end of that article. Now, I don't know about you, but I for one could totally get behind a theory like that. All of Abraham's points seem to add up pretty well, and he had some pretty solid evidence. And I heard that he's not the only person at Harvard who thinks that, and there are a few other scientists that agree with him. But I also just like the thought of there being other civilizations apart from us out there. Aliens have just fascinated me, kind of. And I hope that sometime, even if it's bacterial, we discover some kind of alien life. And I think on the pathway that we're on right now, it could happen relatively soon. But anyways, that's about all I have for this article. Let's move on to the next one. For our second and final article, we have "This is what a supernova sounds like according to NASA." Now, I find this article especially interesting since, for one, there is no sound in space. You can't hear anything in space and no one can hear you in space. So I'll love to see how they manage to get at least an estimate at what a supernova sounds like. So let's jump into it. NASA's new project turns up the volume on space's most extreme phenomena. Oh boy. In space, nobody can hear you scream, or explode, or collapse, or slowly collide with a neighboring galaxy. But now, thanks to a new data sonification program at NASA, you can at least get a sense of what some of the most extreme phenomena in the universe might sound like when converted to sound played by earthly instruments. To hear what that sounds like, we turn to NASA's Chandra X-ray Center, which has been imaging distant galaxies with its Chandra X-ray Observatory for 20 years now. Apparently, just seeing the wonders of the cosmos was not enough for them. In their new initiative, Chandra researchers have taken 3 iconic images from their archives and translated different frequencies of light into different pitches of sound. Take the following video of the Crab Nebula, a supernova remnant powered by a windy neutron star. In NASA's data sonification of the nebula, X-ray light, blue and white, is represented by brass instruments. Optical light, purple, is played by string instruments, and infrared light, pink, is represented by woodwinds. The pitch of each instrument family increases from the bottom of the image to the top. So many tones are audible at the same time. The sounds converge near the center of the nebula, where a rapidly swirling pulsar is blasting gas and radiation in all directions. Listen below. Now, I'm not gonna play these. I think if you wanna listen to these or watch them, you can go on them yourself. I will have a link to this article in the description, so you can watch these whenever you like. But for now, I'll just carry on. The agency posted 2 more videos in a statement. One shows the bullet cluster, two clusters of galaxies slowly colliding with one another about 3.7 billion light-years from Earth. This collision provided the first direct evidence of the existence of dark matter, which is causing distant galaxies in the two blue regions of the image to appear larger and closer through a process called gravitational lensing, according to NASA. Those blue dark matter Y regions are represented with the lowest sound frequencies in the video below, with X-ray light represented with the highest frequencies. Again, I won't play this, I'll just carry on reading and you can go check it out whenever you like. The final video shows a supernova explosion called Supernova 1987A, named for the year its light first reached Earth from the Large Magellanic Cloud, a satellite galaxy about 168,000 light-years away. Unlike the other two videos, which pan over the image from left to right, this supernova gets a special time-lapse treatment, as a crosshair swoops around the edge of the nova's gassy halo. The image gradually transforms to show the explosion's evolution between 1999 and 2013. The brighter the halo becomes, the higher and louder the pitches sound. The ring of gas reaches peak brightness as the supernova shock wave ripples through it, according to NASA, resulting in the loudest, highest pitches at the video's end. So now, you can tell your friends what a supernova, a neutron star, and a great heap of dark matter sound like, in one sense of the way. Surprisingly, that was the end of that article. It was a relatively short one. Both were pretty short, but that one especially. Of course, just because I read through the whole thing doesn't mean you can't go check them out yourself, which, again, I recommend. But I'll share my opinion on this one and we'll end it off. So I think it's pretty cool that we can now know kind of what these events sound like, but not naturally in an instrumental form. And I think that's cool because while I was recording, I watched a little bit of the first one, and it sounded like it had a relatively consistent rhythm to it. Imagine if we could be making songs out of these. That would be pretty cool. Now, as for what they said at the end of the article, I think they kind of missed it on the relatability factor because not a lot of people I know, or anyone for that matter, I think, talk to their friends about what a supernova sounds like. But besides that, the article was very interesting, and after I record this, I'll check out the rest of those clips. But for now, I think that is all. With that said, be sure to like, subscribe, and turn on that notification bell if you really enjoyed the video. And I will see you next time, maybe with my face, maybe not. Anyways, see you later.